In contemporary production applications, slow database queries function as hidden performance detractors. A query that takes seconds instead of milliseconds leads to increased latency, slow API responses, and soaring database CPU usage. Identifying database bottlenecks typically involves conducting an execution plan analysis. This process requires examining nested loops, expensive full table scans, absent composite indexes, and intricate subqueries. For backend developers and database administrators, manually profiling and rewriting numerous complex queries is often laborious and time-consuming. Today, we will explore automating SQL query optimization through the use of large language models. Welcome to Creative AI Lab. Modern language models are proficient in comprehending relational logic, indexing methods, and database execution trees. When provided with a slow query along with its execution plan and table schema, an AI model can swiftly identify bottlenecks. It can detect unindexed foreign keys, recognize implicit type conversions that bypass indexes, and suggest improved join orders. To ensure safe and reliable query optimizations, your prompt must encompass the appropriate context. If you solely provide a raw SQL statement without detailing the schema or dialect, the model will make only general assumptions. To obtain production-ready outputs, 3 vital inputs are required. First, specify the precise database engine and version, like Postgres 15 or MySQL 8. Second, disclose the relevant table schemas, including current primary keys and existing indexes. Third, supply the raw output from your database profiler, such as the results from an explain-analyze command. Your system prompt should assert strict optimization guidelines. As a principal database engineer and performance architect, analyze the provided SQL query, database dialect, schema definition, and execution plan. Identify performance bottlenecks such as sequential scans and temporary disk writes. Rewrite the query for optimal execution efficiency, explain the mathematical reasoning, and suggest any required indexes. Return exclusively the optimized query, index creation commands, and a brief summary of potential performance improvements. Next, let's examine how you can automate this analysis via a lightweight Python script. Begin by setting up a Python script that processes your slow queries and their corresponding execution plan logs. Utilizing the OpenAI API, we send our specialized system prompt along with the input query. The script forwards the execution profile to the model, analyzing cost metrics and generating a revised query with suggested indexes. The script then saves the optimized SQL file, providing an architectural summary that clarifies why the new query performs faster. You can incorporate this tool into your local development environment or run it automatically against slow query logs captured in your staging environment. This enables your team to identify costly database bottlenecks well before they affect production users. As always, adhere to the essential principle of database administration. Never deploy an AI-optimized query directly into production without rigorously testing it against representative data in your staging environment. Leverage AI to reduce profiling efforts by 90%, validate the execution plan, and deploy confidently. Automating database optimization ensures your application remains fast, scalable, and economical. In Part 5 of this series, we will integrate all concepts in an advanced architecture tutorial. We will explore building a private, local retrieval augmented generation pipeline with lightweight vector search. Click on the video present on your screen to view Part 5. Remember to subscribe to Creative AI Lab to master automated technical workflows.